This presentation will investigate a solution to a mathematical problem. The problem concerned relates to the issue of environmental sustainability, which is a cross-curriculum perspective within the Australian curriculum. An analysis of the issue involved and possible solutions to the problem will be presented that aim to lessen one's environmental footprint. This presentation will be structured following Polyer's four-stage classic model of problem solving. The first stage of this process is understanding what the question is asking. This slide displays a mind map of a number of components relating to the issue of solar energy. These are listed as advantages on the map. The mathematical problem we'll be focusing on is whether solar panels generate enough energy and are economically viable to ensure their feasibility. To sum up the focus, we are investigating the environmental impact that are expected by installing the solar panels. Secondly, we will analyse the financial implications for the reality of manufacturing solar energy. Thirdly, we will consider the benefits socially, economically and environmentally. Polyer's second stage is making the plan. This requires deeper thinking about the problem. What information is required to find a solution to this problem? Using an electricity bill to investigate the readings of calculated energy use will be helpful. This will also provide evidence about the amount of energy returned to the electricity grid by the solar panels. Reductions in the amount of electricity taken from the national grid will also be evident, and the financial offset provided by credits gained by feeding back into the grid from the householder will also be apparent. In making a plan, we will access information from websites and the Energy Australia's consumer bills to collect information about energy usage for a residential setting. Information from websites will be reviewed to determine the cost of installing solar panels, as well as the background information about the conditions in which this system performs best. As we continue to make our plan in this phase of Polyer's process of problem solving, we will determine what information we will need and what mathematical skills and strategies might be most helpful. Some of the areas of mathematics that might need to be explored which link to the problem include the use of concepts such as number, investigating the kilowatts used and the money, operation, adding and subtracting energy amounts and the money, estimation, making approximation about the time frame to pay off the capital expenditure for solar panels, constructing a table to clarify the data, working backwards by using known data to form a clearer perspective. The plan we have chosen to follow initially is to create tables that can help set out our information. Guess and check strategies will also be implemented. The first piece of evidence to be considered is an electricity bill for June. At the top of the page, the raw data will be taken and placed into a constructed table. Placing the data into a table is one of the first of 7 strategies which can be implemented in order to assist in the operation for this mathematical solution. What is evident in this table is that the period of observation, the production of solar energy is limited and the cost reduction minimal. There are many factors for this, including the autumn season, having less hours of sunshine and more cloud coverage. Using the mathematical process of addition, the amounts of kilowatt hours have been totaled to give an overall usage readout for both the retailer's provision of electricity and the household's generation of solar power. The same process has been applied to the charges or the consumption costs and the savings obtained by the household. In comparison, this bill for December demonstrates a greater production of solar energy. Consequently, because the household is able to produce more solar energy, more energy is returned to the grid, enabling the householder to be credited money for the contribution. What is evident in this billing period is the solar panels can produce almost 1/3 of the daily energy requirements for the household. This is quite significant in terms of helping to lessen carbon emission caused by burning of fossil fuels. The table below is the corresponding savings to the environment in the kilowatts per hour produced and the savings to the household budget in terms of the consumption cost savings. When installation costs are factored in, it becomes evident the cost effectiveness of installing solar panels can be questioned, at least in the short term. Using a guess and check strategy, we can determine the feasibility of our solution to install solar panels from a financial and environmental point of view. With a rough figure of $200 savings made in spring, if the same were true for the 3 other billing periods of the year, then a total of approximately $800 could be expected. This figure is arrived by multiplying 200 at 4 billing periods. As a guess, this $800 per year saving over 9 years would achieve $7,200, which is within the range of the solar panel costs. So the reality is, whilst it may be environmentally appropriate to install solar panels, especially during spring and summer, the results are not as successful in winter or autumn. However, there is less consumption which benefits the environment. Financially, solar panels are a significant burden, whilst there is some return on the householder's investment.